Hey, what's up guys, this is Krishna here. Welcome to this exciting project walkthrough of Vellum Puppet Crowd. I submitted this for Side Effects Houdini Challenge Day 23 called Skeleton Blend. Okay, let's jump right into it. So this is the overall scene here. Okay, I have a bunch of character animated or animations. So let me go through this first. So if you type in mocap piped, you get these options. These are inbuilt in Houdini. Okay, so I chose Biped 2. So if I look at this one, let me just get rid of these here. If I look at this one here, so it's just this character and it's a rest animation. Okay, it's in place, and that's important. Okay, and then I have a walk normal. Okay, and the texture is 3. So if you change the texture, you can get different textures here. So I chose texture 3 for everything. And walk fast, okay, here, and then jog, and then running, okay, this one here. So if I play this, you'll just see that. Okay, it's in a cycle, so you don't see it like much different. I think they're 63 and 64. Okay, it's glitching a little bit. So this geometry container here called animated is where everything happens. Okay, so let me dive in. So first I've got agent node where I bring in the rest animation. Okay, and then I call the clip name to be rest here. And then I use agent clip node where I set the current clip, and I bring in the rest of the clips as well here. Okay, I didn't bring in rest clip here because that's part of this here. All right, just so that you know here. So but the first clip is rest, the second one is walk normal, third one is walk fast, jog, and run. Okay, so those are the clips. So the idea behind it is so that it starts off in the rest position, and then it walks normal, and then walk fast, and then jog, and then run. Okay, so it just happens sequentially. All right, so the next is I bring in the agent animation unpack. It's literally nothing, just drop that in so that I can get the bones or the rig. Okay, so this is where really a lot of things happen. Okay, so if I explain what's going on here, right? So set bias, sorry, this is the one. So I'm gonna just choose this here for the moment. Okay, so if I play this, runs, walks, jogs. Okay, so from rest position he walks, and then walks faster, and then starts running or jogging, and then he starts running. Okay, so you see at exactly 127 and 128 there's a glitch. Okay, I'm going to eventually cut this animation at 127. You'll notice that later. Okay, so how is this happening? It's because if I look at the skeleton blend, so if I run this, it's just walking in a cycle. Okay, so that's basically skeleton blend node. Okay, and these are all default except for bias attribute. Bias attribute is the attribute that defines how it's biased from one position or one animation to the next. So this is from the rest to walking. So for an example, if I put in a skeleton blend here and choose what is this, walk normal to walk fast. Okay, so nothing. Okay, so there you go, he's walking. Okay, but if I choose this bias, you can see he's now going to be walking faster. Okay, so it's probably not a good idea. Like, let me just put into run. Okay, so he's now running, as you can see, but if I change this to 0, he's just walking. And this is important because if I were to choose $F divided by $RF and okay, so bias starts from 0 point whatever. By 288 frame, bias will be 1. Okay, so if I play this, he's walking and then he's struggling. Eventually starts running. Okay, so that's the idea behind it. All right, so I just wanted to show you. So what am I doing with that? I'm saying that you will be based on an attribute called bias1, which is set here. So what is this all? So I'm creating a float value called lot. Okay, and I'm saying you'll be $FPS, which is frame per second, multiplied by this channel duration, which is 1. So effectively lot will be 24. That's it. So 24 multiplied by this duration 1. Okay, because this is a 24 per second project. So f float at bias1 then is equal to at frame divided by lot. Okay, which is the current frame divided by the lot, which is 24. But I'm also saying you'll be a minimum of the two. So for an example, if frame number is 24 divided by lot, which is 24 as well, so that'll become 1. After the 24th frame, this will stay 1. That's why I have this minimum. Okay, so minimum of the two will be outputted to bias1. Okay, so then I'm going to bias2. So if I'm saying when you bias1 is equal to 1, which it will be on the 24th frame onwards, bias2 then will become this value, okay, which is at frame minus lot, which is if the frame number is 24, the lot number is 24, and 24 minus 24 is 0. So that'll start from 0 basically. And I'm also clamping this value from 0 to lot, 0 to 24. Okay, and I know it's kind of complicated, but this project is available on gumroad.com. Please support me by purchasing it. But basically, you just need to copy this and paste it, and you'll understand. So basically, what this in a sense doing is that up to 24th frame, it'll look for bias1. From 24 to 48, bias2. 48 to 96, bias3. 96 to 120, bias4, and so on. Okay, so if I now pull this one here, I've just filtered all the bias. Okay, so you see here bias1. Okay, so on the 24th frame, bias1 is 1. Bias2 is still 0 throughout up until 24. And from 25, bias2 starts. From 48, bias3 starts, and then so forth. Okay, so at about, yeah, so up to 120. Okay, it continues to go on. So that's what these are. Okay, so what am I doing with that? So first skeleton blend will look between the rest position and walk normal, and that'll be set to bias1. And then this next one will be a combination of these two, and then walk fast, which will be set to bias2, and so forth. You can see bias3 there, and this is bias4. And basically that will mean it will rest, to walk fast, to jog, to run. And from 100 frame is fine, 120th frame is fine, but at 128th frame you can see that there is a glitch. Okay, so that's where I'm going to cut out our animation. So what am I doing with this now? I'm bringing an agent pose from rig, so you need to match up the mesh to the skeleton. Okay, so you just put that in and connect the agent to the first input and the skeleton to the second input. Okay, so that's that. Okay, so on the left hand side here, I'm creating puppet strings where I'm bringing in the agent and I'm unpacking that agent so I can have geometry. Okay, so it's got 8,993 points. Okay, without it you only have 1 point. Okay, oh, there you go. So I'm deleting, isolating the feet, and I'm isolating head and hands, and isolating hands, basically isolating head, right hand, left foot, right foot, left foot. So why am I doing all that? Is to create points where they are, and they will go in line with where their current position is. This is so that I can connect the strings to make it like, it's a puppet and whatnot. So I'm creating a line and grouping the top one to one, first point to keep group, and then the bottom group to be this one. Well, I should have really put in a 0 here, but anyway, now it is there. I'm extracting centroid. Okay, this is a great node, so you can extract centroids off the primitive. And then I'm creating an orientation. I'll come to that, but I'm basically copying these lines to those points, and if I get rid of the orient, it looks straight. Okay, so if I template the actual agent itself, so I wanted the strings to come out that way and then go up. If I don't have the orient, it'll just go straight up. I didn't want that kind of, it went through the mesh. Okay, so and they are the settings. So if I adjust the cone angle, you'll see that it'll change its position. All right, and that's basically it. And then I have given it random colors. Okay, so it all got random colors. That's about it. And then I'm blasting just the keep node, keep point, which is over here, so I can create a vertical line from there. Okay, so again, creating another line, grouping the bottom, or remove group to be the bottom one. All right. Again, creating random colors, and I'm copying those points. Okay, so in a sense, you'll have this. Okay, so, and they will move with the character animation, which is perfect. Okay, so I'm clipping at a distance, so if I look at the cam, you can't really see here, but if I choose this one, it's gone crazy. Okay, basically I'm clipping all of them because I didn't need any further than that. Okay, and I'm deleting remove and bottom group. So what does that mean? So I'm removing this. Yeah, I'm removing this bottom group here. Okay, and I'm removing the bottom group from up here somewhere. Where is it? There, that one. Okay, and I think this is why there was a problem. Okay, so that's fine. Okay, and I'm transforming that to the centroid, so all of them stay in the centroid. Okay, so there and there. Okay, and then I am connecting the adjacent pieces so I can create some sort of handles for the strings. It's not perfect, it's not ideal, but hey. And then I'm creating a sweep so we can get some cylindrical pattern or tube kind of thing. Then I'm merging them too. On this side I'm doing pretty much the same basically, except this one is transformed to the center. Okay, because you want this as well as this. Okay, so because then you have the sort of a plus or a cross sort of thing. Yeah, there you go. See. Okay, and then just closing out any of the gaps that are around, and then I'm creating a group called handles. Okay, so I'm combining the handles and I'm combining the strings, and the clip is so that you can put it right there. Okay, and also I'm combining the agent here now. Okay, so in a sense what will happen now is it'll look like the handle's moving and the strings are moving and he's running. It's like a puppet. But this thing is not great looking at the moment. But for the camera angle, it was fine for me to just leave it like that. It's not ideal, as I said, but it's okay. All right. So what is happening next? I'm creating crowd here now. Okay. So binary grid, and at the end of the grid, I have all of these guys in place because it's not exactly crowd, but I'm copying those guys across onto the points on the grid. Okay. So it's just a regular copy to points. I'll come to the time warp shortly, but I basically pasted them all here. Okay. So where's the grid? So the grid is at the bottom. Okay, good. I can't really see anything here. So I'll change the light. Okay. So I'm isolating agents. Okay. And I'm unpacking them. And then I'm assigning them a material. And then I'm bringing in just the strings, and then I'm bringing in just the handles. Okay, so they're all together now. Okay, here. And what's happening here in the time warp is that if I were to play this for you without the time warp, they'll all start exactly at the same time, and they'll all do exactly the same thing at the same time. I didn't like that. I wanted a variation, so I created this time warp here, whereby I'll say, right, so give me the detail iteration, okay, from the metadata here. Okay, give me that, and give me a random number of that iteration, and then fit that random number between -24 to 24. So basically you've got a 48-second difference between the start of it and start of the animation and the end of animation. Okay, these are numbers that I figured it's 24 frames per second animation. Therefore, I thought, okay, 1 second before and after would be perfect, and I set the input frame range to be 127. Okay. And that's the number I was talking to you guys about earlier, okay? Where in the 128th second, we saw a glitch, okay? So pre-zigzag just means that it'll go forward and backward, okay? It won't just stop. It won't hold, extend, or cycle. It'll go forward once and then reverse once and forward again, okay? It's the same for pre and post. And I've unchecked interpolate between input frames because I don't need any of that. I have all the frames that I need. I don't need any interpolation. Okay, so now if I run this, these guys will start. You see here, this guy's still standing. Some of them have started walking, etc. Okay. All right, good. So I've explained all of this now. So visualization is complete. Okay, good. So let's move on to Vellum. Okay, here I am getting the agents. Okay, so object animated out agents. Where's that? Animated out agents. This guy here. Okay. All right, and I'm saying, okay, I want the last frame, which is 240. Okay, it's not the last frame really. So I've got 288 frames here. Okay, but 240 was the right frame I figured. Okay, and then connectivity. We'll just create an attribute called class so that I can differentiate from one agent to another. Okay. Each one of these agents will have their own class attribute. And then I'm going through each one of them and converting them to polygon. Okay. So now you can see there are 377,000 points. Without it, prims. Without it, it's only 168 prims. Otherwise, 369, 474 prims. Okay. So all of them is being fed into this Vellum cloth. Okay, so every one of them will become a Vellum cloth. And then I'm getting handles, as you can see up here. And again, the same frame number, 240. This will be Vellum shape match because I wanted it to be like an RBD kind of thing, rigid body. And then I'm getting the strings, again the same frame time shift, okay, so that I don't get the animation itself. I only get one frame off of it, okay. And then I'm fusing them just a little bit, so there's 627 points after fuse. Before that it's 840 points. Okay, I'm cleaning it up basically, and I'm resampling it with the curve U attribute enabled. I'm not sure if I'm using it down here, but anyway, we'll see. Group, yeah, I am. So I'm saying you'll be pins group if curve U is equal to 1, which is the top one basically. Okay, so the reason behind that is because this is a primitive and that is a primitive, okay, and I wanted to pin both of these, okay, and I'm saying the bottom one will be deleted from the pins group, so I only want the top one basically. Could I have done it without? Yeah, you can't, because these are two separate primitives, so that's why I had to subtract it with bottom group so that I can delete this one and just have this one up top. Okay, so I then give it hair, Vellum hair. Okay, so these are the settings here. So I think these are default settings, to be honest with you. Maybe I changed the stretch stiffness a little bit, and then I'm attaching it to the so Vellum attach to geometry, so I'm attaching the pins group. Okay, so that's basically it, and I'm combining the geometry constraint and collision into 3 separate merges, and then I'm feeding them into the Vellum solver. Vellum solver, it's just basic stuff. The ground plane is set to just ever so slightly below 0, okay, and the substeps of 4. I don't think I added anything else here, to be honest with you. Inside of it, there's nothing going on, nothing special. Okay, so once the sim is finished, you see these handles are up here. That's why I didn't bother. I didn't mind that being not so great. Okay, all right. And then after the sim, I'm isolating. What am I isolating? Agents, simmed agents, simmed handles, and simmed strings. Okay, so yeah, this is going to take a while if I start simulating it, but anyway. Okay, I'm not going to run the sim, but basically what it is doing is, if I've got 3 frames here, okay, so second frame, you can see it's starting to go down. As you can see, his foot here is starting to take the shape now, because they're just falling apart now, because they're literally just cloth, cloth. Okay, so if but I have an animation here, and then I have the Vellum. So how do I combine these two? So if I go into render character, let's go through this. Okay, so what am I bringing here? So I'm bringing in the agents, and I'm bringing in the simmed agents, and then I'm using a time warp to say shift frame 241 frames. It's shifted. The input frame range is 1 to 240, because that's what I selected for the animation. Okay, so then I'm creating a normal just in case, and then I'm switching the input from the animated agents to the Vellum agent after frame number 240. So up to 240, these guys will just continue performing the animation, and once it's gone past 241st frame, it'll switch to the Vellum, which now has been shifted using this time warp node. Okay, I hope you understand that. Okay, so that's character, and I'm basically doing the same for the handles, and I believe it's the same for strings. Yep, that's right. Except strings, I'm using polywire for render. I usually select I usually just select this one, render objects as strands, but that would mean that it'll be a flat strand. Okay, I didn't want that. That's why I created polywire. That's about it, really. And then I'm also rendering the grid here. Okay, so that's basically everything about the project. Okay, and then I've got a Cam 1, which is 720p, and I'm using depth of field, and these are the values for depth of field. Okay, Redshift, no post. Oh, there is it's OCIO display. That's about it, really. And there is your current camera position. And as far as the dome light is concerned, I have Photo Studio HDRI, which is available for free from polyhammond.com. I'll leave a link in the description. Check it out. Okay, so that's that. So let's move on to the actual materials. So the character itself will they have their inbuilt materials when you install side effects. So what I'm doing is I'm bringing that across to here in Redshift. The way to do that is using this op def function. So if you just type this in, it'll come up. And if you middle click on this, it won't show up anything. But when you do the render, it'll just work fine. Okay. As far as the material is concerned, I use the preset here, plastic, and nothing else changed really. And then the grid is just a simple paper material, and there are your settings here. Okay, it's not a big deal. And then strings, I used plastic again, and I brought in the color attribute, so they all have different colors. Okay, which we've already defined. So out, I've got Redshift node here where I'm only rendering the RNDR prefix nodes. Okay, so these are those. Okay, so there you go. There they are. And then output, just standard. I think by default it's like that, but I didn't want that. Okay, so there it is. I didn't create any AOEs or anything. For Redshift, I enabled denoise, automatic sampling, and of course motion blur and global illumination. Okay. In the system, I increased the bucket size because I have RTX 3090 GPU, so it can handle the bucket size. In fact, it can handle 512 as well, I think, but I never really tried it. So that's all of the out thing here. Just wanted to let's go back to this. For velocity blur to work or motion blur to work, you need to enable this mesh deformations blur from velocity attribute for all of it, really. Not these ones. This one, yes. Here. Okay. So that's the end of that. As I mentioned before, it is available on gumroad.com. Please support me by purchasing the file. I really appreciate it. I hope this was helpful for you. If it did, give me a like, thumbs up, comment, share, subscribe. I really appreciate it. Until next time, have a good day.